Hey everybody. So today just wanted to kind of show how we can incorporate different GPS sensors with LabVIEW. So kind of for this demo, I have this Adafruit Ultimate GPS, GNS with USB. Kind of cool. Basically just connect over USB. You also can connect right to the pins here if you wanted to. And yeah, it'll just show up like a COM port. So you can basically go and um, uh, connect it to a computer. You can connect it to an embedded controller. You can connect it to an Arduino. Basically anything, and just use serial commands to control it, to configure things, and to get data back. And then one thing, it doesn't come with an antenna, so you can see where the antenna plugs in here. It doesn't actually come with one. You can connect this guy. It does work without the antenna, just not as well, so you probably want that. Then you also can add a battery to it as well, so it can work even if like USB power gets cut or something like that. But yeah, pretty cheap, 30 bucks. You can add, GPS technology, and they have pretty good examples and documentation and whatnot on different commands and, modes you can put this in. And they also have free software you can use to kind of configure these and to manually test stuff, which is pretty cool. So yeah, this is the one that I have connected to my computer here. So I have just this example here, so I can run this. Basically here I get my NMEA codes from the device. So you have this $sign and then these characters, so either GP or GN, and then 3 characters after. So these define different bits of information that the device can return, and I'll show you that. And then over here it's extracting different details from that GPS sensor. So you will notice a lot of stuff just reading 0. Kind of just as a bit of a disclaimer, I am inside of a building right now, far away from windows, and I don't have an antenna attached, so it just doesn't work very well in a building. This was working great when I was testing it outside before. So yeah, you will want to make sure you have good view of satellites. So yeah, just if you're planning on using this inside your facility, it's probably not going to work all that great. Depending on where you're located, you can, do some stuff to try to improve that. But yeah, and like I said, I don't have an antenna attached right now. So I'll show you a little bit of the code. So you can see I'm just using a VISA open. So I'm connecting to the COM port that it shows up as and using a VISA open. I'm setting the termination character. So this uses a end of line constant, which is basically a carriage return and line feed. So I'm setting that. Then I'm sending it a couple of commands to configure it first. So I'm using this PMTK set NMEA output RMC GGA, which basically just turns on the recommended minimum and fixed data. And then we're using this set NMEA update 1 Hertz, so it's just going to update once a second. And I'm using this PG CMD no antenna just to let it know that I don't have an antenna attached, so be in no antenna mode. If you have an antenna, you don't need that, obviously. Yeah, and then here is where we're actually parsing those NMEA commands. So if you're interested in these NMEA commands, this is a standard, so you can go look these up. You can find detailed information. I basically took from the manual for this device, these different formats, right? So GGA is Global Positioning System Fixed Data. So you get this GP GGA command, and then it's just comma, data, on and on and on. And these tables actually break down which information you're getting. So you can see, I'm getting, time data, longitude and latitude. You can get speed, you can get direction, you can get, all sorts of different stuff. So right, you can see your speed over ground, your course over ground, etc. So you can use this for things like, hey, if you're testing a vehicle, right, a car, you can have this in your vehicle, and you can be logging location data, speed data, etc., while you maybe have thermocouples or whatever connected to your vehicle, so you can correlate like physical location and speed to, your data off your vehicle, stuff like that. So kind of cool. So yeah, we're just doing a VISA read. and this is basically just relying on that termination character to denote the end of a message. Here we're just basically building that list of NMEA strings. So you get the string, and then just builds that list so you can keep seeing all of your NMEA strings. Here we're doing just a little bit of searching, and we're basically extracting that first element in that string. So that's going to be this code here. And then we're just going in here and breaking apart, different components of it. So if we get like a GNGGA, we're going to extract from that the time, latitude, and longitude. There's different ones here. I haven't gone and mapped everything. GNRMC, we are extracting all this information. So yeah, basically just breaking apart that delimiter that is that comma. That's basically it. So we can then read all that data in, and we now have GPS connectivity in LabVIEW. So I can track all sorts of information, where I am physically, what direction I'm traveling in, what speed I'm traveling in. It can do stuff with date and time. The date and time, I can show you. It doesn't necessarily know which time zone you're in, so there's just this constant here that's offsetting for time zone. So yeah, basically just taking the time that's returned and then offsetting that. That's basically all it takes to connect to this in LabVIEW. There's a whole bunch more commands you can use as well to configure things different ways. And this one will actually do up to 10 hertz, so you can get even faster location data, which is pretty cool. Really pretty simple, just some simple VISA commands, and you're off to the races. So that would be how you can connect the Adafruit USB Ultimate GPS module to LabVIEW. Thank you for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.